Okay, hi. So in this video, we're going to speak a bit about obtaining electricity from fuels. Now, the number one method that we produce electricity is via a power station. A power station. Okay. Now, there are three main types of power station that we're going to mention. One of those is a coal-fired power station. The next one is oil fire. And finally, a gas-fired power station. Okay, there are of course other types, but these are the ones we're going to speak about. Now, rather than draw a really complicated diagram of a power station, what I'm going to do is just show you the main parts. So what we have, this is meant to be fire, we have a furnace. Okay, so we have a furnace. And what this is going to do is it's going to heat up water. So we'll have some water coming in. This will be in a pipe, obviously, so that the water's not actually on the fire. So water will come in, it will get heated up. And then, obviously, as you heat up water really hot, it turns into steam. So the water turns into a gas, and then that moves away. Now, what that steam will do, because that steam is moving, it's going to turn what is known as a turbine. So a turbine. Let's just say that this wheel here is a turbine. The water is going to run past this turbine and cause it to start spinning. So the turbine will start spinning, and that turbine is going to be linked to a generator. Okay, just going to do that in a different colour. To a generator. Now this generator will start spinning as a result of the turbine spinning, and then the generator will produce electricity, which will be our output. So that will produce electricity. So output electricity. So of course on the furnace, what we're burning in the furnace is our fuel, so that is going to affect what type of power station it is. We'll also have loads of other safety features and things like that, but this is just the main way in which a power station is going to work. Now, one thing is that in a gas-fired power station, so I'll just put a little star here, in a gas-fired power station, sometimes we don't use water and steam. Sometimes we can just heat natural gas directly, and the natural gas will turn the turbine, which will turn the generator. But you can see that there are a lot of similarities, and that's why I've grouped them together like this. Now, coal and oil-fired power stations are very common because, of course, that is a fuel which produces a lot of energy, and it's one that we can find quite a lot of. They are fossil fuels, and so we are looking for other methods. A gas-fired power station, because, of course, we can put the gas in straight away without having to heat the water, this can be turned on very quickly. Let's just write that slightly bigger. There we go. So these power stations can be turned on and off very quickly. Now that's great because if, for example, at like 7 PM when everyone gets home and they put their heating on and they start watching TV, you need more power really quickly. And so if you're providing a constant amount of power, we can provide a bit more by firing up some gas power stations. Okay, so I mentioned that these fuels are finite resources and non-renewable, and that's only partially true because we can use what are known as biofuels. I know you all have heard this term before, but just to recap, a biofuel is a fuel from a once living organism. Okay, and these are actually renewable because we can constantly grow plants and therefore we can constantly have this supply. So these are renewable. And if we use this as the fuel in a power station, it means that we are actually being more sustainable. The reason for that is because they are carbon neutral. Now, some people will argue that they're not 100% carbon neutral, but they're very close. And that's because the carbon dioxide which a plant has taken in during its lifetime will then be released when you burn the fuel. So whereas with natural gas and oil and coal, that carbon is buried in the ground and it hasn't been taken in from the atmosphere anytime recently. Whereas let's say you have dead plant matter or feces from animals or whatever, and that's going to be burnt, well, the carbon in there was taken in by the plant or the animal, and so all you're doing is you're giving the carbon back. There's no net increase of the amount of carbon in the atmosphere because that organism took in the carbon originally. Okay, so it's what's known as carbon neutral because the amount of carbon is being balanced. Okay, so finally, one more way that we can obtain energy, rather than using these three types, is nuclear power. Nuclear power. Now, although some of the processes are very different because we're not going to be burning a fuel, so you're not going to have this furnace, what you will still have is energy being released which can heat steam, turn a turbine, and therefore have an output from a generator. So it's still fairly familiar to what we've looked at already. So this is sort of a slight crossover with chemistry. Nuclear power actually uses energy contained in the nucleus of an atom. So in an atom, we have protons, neutrons, and electrons. So protons, neutrons and electrons. Now I've done the electrons in a different colour because they're not found in the nucleus of the atom. So it's the protons and the neutrons that we're really interested in. And what we do is we take a radioactive substance, so either uranium or plutonium, and what happens is these atoms can be split apart, and this is a process known as nuclear fission. So nuclear fission. Okay, we don't need to know too many details about this, but nuclear fission releases lots of energy. So lots of, sorry, that's awful, energy. Okay, now because atoms are going to be splitting apart all over the place, we're going to get a tremendous amount of energy released, and this will release a tremendous amount of heat. And the heat is transferred to a liquid known as the coolant. And this coolant then goes off and it heats the water. Okay, and so if we go back up to our diagram up here, what happens, instead of a furnace, we have a coolant coming in, and the coolant will then be close to the water, and that will turn the water into steam because the coolant will get so hot. Okay, and that is going to happen in what is known as a heat exchanger. Let's just put this in a different colour. So that is via a heat exchanger. So in the heat exchanger, the coolant will then heat the water and turn it into steam, and that will go on to produce our electricity. Okay, now a nuclear power station, so nuclear and a fossil fuel power station, so fossil fuel. If we compare the two, we see that a nuclear power station will produce way more energy than a fossil fuel power station per amount of fuel. So more energy, less energy. Okay, it's actually about 10,000 times as much if you use the same amount of fuel. And so we might think, well, why don't we use nuclear power stations all the time? Well, the downside, let's just do this in another colour. Downside is that this produces nuclear waste, and the nuclear waste is radioactive material. That radioactive material needs to be stored for many years. Stored for years. And this is difficult and expensive, and a lot of the time we bury this nuclear waste in places which are not inhabited, such as into the sides of mountains and things like that. Whereas fossil fuels do not produce nuclear waste. No nuclear waste. And so fossil fuels are more convenient in that way. We don't have to get rid of this waste. Okay, so I'm going to wrap up there. I hope that's helped understand these different types of power stations and the different fuels. If you do have any questions, please do feel free to give me an email or comment in the box below, and I'll be sure to get back to you. But I look forward to seeing you in the next video.